We are now going to the next speaker, to Mr. Paul van Ham, the CTO, developer and producer of the EOX from the company H2 Track in the Netherlands, not in UK, as you pointed out, of course. You have background and study in agriculture techniques and soil science, and as a result of a thesis, you developed the EcoPlow. And you work with different kind of organic agriculture, and also with the Dutch Ministry of Agriculture. And Paul met a group of farmers working with the so-called controlled traffic farming, CTF, and started a study group on the mechanization for sustainable agriculture. And this resulted in an innovative tool carrier for this CTF, controlled traffic farming, and the first electric tracker for the market, the EOX 175. And this is the topic for the presentation, the use case, real case of EOX 175. Welcome.
Thank you a lot, Chairman. And you also thanks for inviting me and hearing all and presenting all these nice stories. For me, it was quite interesting to hear what is all happening about in this world. Myself, I started some 10 years ago with a question for farmers, and it was not about electrifying the agriculture. That was just because they want to have a smart machine for their agriculture. And somewhere in the process, we took the right line, I think, to make our machine electric driven. And the next step is to make it even with a hydrogen energy solution. So then we have a complete emission-free machine. So my name is Paul van Ham, and I'm the founder and the technology director of the H2 Track. And our machine is in fact called the EOX, meaning something like electric ox. And the ox, in fact, was the first tractor in the world. Here you see the machine driving around. There is some noise, of course, but somewhere in the technology that is missed. There it is. This sounds like an electric tractor, and in fact what you are hearing is the hydraulic pump. So there are no hydraulic pumps that doesn't make noise. Normally you don't hear them because the diesel engine is making even more noise. So we are also looking for a silent hydraulic pump. So when one of you have that, I'm very eager to see that. We built a first zero-emission electric tractor with hydrogen that is built now, actual in my workshop in Arnhem in the Netherlands. We are building this machine. In fact, it is quite a normal tractor when you look to the features, so it can do everything what a tractor can do. It has a very compatible total cost of ownership. It is circular build and quite economic. We have a modular bolted frame where you can change a lot of things if you want that in the life of the machine. We have this zero-emission solution with a 100% electric drivetrain. And we have very much possibilities on the bolted frame to have all kind of tools and equipment placed there. We started because our clients ask for zero emission on construction sites and in agriculture. What you see is 4 big wheels, within every wheel a strong electric motor. That is a nominal power of 22 kilowatt and a maximum power of 44. So times 4, that is almost 220, 230 horsepower force, and so torque in electric ways on the wheels. All 4 wheels are steered. We can vary the tires from very narrow to quite wide. We can extend the battery capacity in discussion with the customer. In our standard machine, that is the hybrid solution with a diesel generator, we have 1 battery block of 50 kilowatt. Also in the hydrogen machine, we have 1 block of 50 kilowatt hour. And when the fully battery operating machine, we can put 2 or 3 blocks in the machine, and then also in the front hitch or in the rear hitch or on top. So we can make quite a fully packed battery machine also. And last but not least, of course, for the driver, a quite wide and comfortable cabin to drive around in this machine. These 3 energy, modular energy configurations I already mentioned, 100% EV, so including 100, 200, 300 kilowatt hour batteries, depending your demand. In fact, I did not start with an electric machine, and in that time my farmers did not specially want batteries. But on this moment, especially in the Netherlands, there is a big demand in construction companies which are forced by their clients to go zero emission. And for the construction sites where you have your charging capacity somewhere around your work, batteries are very interesting. And then with that hitch system, we can make easy swappable battery packages. More for agriculture, I think, is the hydrogen solution. So with only some 5 to 30 kg of hydrogen, you can work the whole day with this machine. And when you can organize the hydrogen support on your farm in one way or another, I think that is a very interesting combination. And then the hybrid, that is just with the AVO diesel, of course, from the former speaker. You have also a quite clean machine with a 20% win on fuel costs. This is the hydrogen machine looking. On this picture, you see only relatively small tanks, but in real life, they are as big that you can sleep in. So they are 2 meters long and 45 centimeters wide. It is 200 liter, and with 350 bar, you can have some 5 kg hydrogen. So that is a bit our bottleneck, I think. That is the density of that hydrogen. We have to find some solutions, or in fact, you have to find some solutions for that, and we can use that later on. This is a very simple concept. It is technically ready, and in fact, together with a big farmer in the Netherlands, we made a project where our machine is driving around after next summer, and he organizes the hydrogen himself. He sells the electricity at his neighboring farm. There is 10 hectares of solar panels lying around. The grid in the Netherlands is completely red throughout the country, so you cannot sell any electricity anymore. So just produce hydrogen for that, store it, pump it up to 350 or a bit more bar, and then put it in our machine. He can drive around. And when that works with one machine, it works with 2 or 3 or 4 machines, and then the truck can tank there and his hydrogen car can tank there, and then we have a little ecosystem. And I hope in the coming 4 or 5 years, we can have some 10 places in the country where we can put these small, locally organized energy production sites for hydrogen. That would be great. A bit more about the techniques. In fact, the concept is simple. The concept of every electric vehicle is the same. The difference with this tractor is that we have 6 electric motors. That makes it a bit complicated. We have 4 motors for the wheels. We have a motor for the PTO, of course. When the farmer needs 2 PTOs, that means 2 motors for 2 PTOs. And we have 1 motor for all hydraulics. So steering the wheels, shifting the wheels to the different track widths is done hydraulically, and also we need some tool helps for the farmer. He needs some hydraulic pressure on the back and on the front for his equipment. Then we have a complete electric steer and drive system, a 4-wheel steering, 2-wheel steering, crab steering, and we can even do O-steering. So then the machine is just turning around his own axle and can move very quickly on very small pieces of land. I talked about the battery possibilities with packages, and then in fact I'm just an OEMer that asks you for a box or 2 boxes or 3 boxes or 4 boxes or 5 boxes or 6 boxes. And then we need good boxes with, of course, the thermal management and a nice cooling system, which we can easily build in. The comfortable white cabin, the control of the whole machine is fully electronic. That makes sense when you have an electric vehicle. We built the complete HMI and the software ourselves, and that is to be 100% in control about the performance of the machine. Range extender, it is or the 120 kilowatt hydrogen stack. That is for us also just a component. So instead of building in the engine generator system, we can build in a hydrogen stack. And that is not that difficult. We built on the hydrogen tanks and the battery package, and we can drive. And then the modular bolted frame, I already mentioned that. So in fact, it is a very special machine because it is looking like a tractor, but technically it is a complete other kind of machine. A bit more about the costs. Always difficult. We are a young scale-up company. We are building not that much machine already, so costs are high. But even then, on the mid and long term, I think service and maintenance will be lower than with a diesel machine, especially with modern tractors. They ask some maintenance cost. Then we have a quite ergonomic cabin that works easy. It is a low noise, so quiet work that also will bring some positive economic value with the machine. And we can sell it, we can lease it. There are all kind of project finance possibilities around the countries in Europe for this kind of machines. So we can use that to make a proper offer to the farmer. In the Netherlands, we see a nice change for zero-emission projects, and with our quite short delivery time, it is a bit depending the component situation in the European Union now, but I think we can build this machine in 6 to 8 months after signing the contract. When we build it in a hybrid version, we have a total cost of ownership that is almost the same as the conventional, or a bit less, and that is more or less because the savings in diesel. And in my old calculation program, there was some 1.2 euro for a liter diesel, and I changed that the last months quite often, and on this moment it is standing on 1.8 euro a liter diesel, and we do not know what it will be next year. The battery costs are also in the total cost of ownership more or less like the conventional diesel tractor, but then you have a 100% zero-emission machine. And the hydrogen machine, that is a bit more difficult because you need to organize the hydrogen supply on your working place, but the break-even is somewhere around 5 or 6 euro for a kg of hydrogen. And that can be done already when you have not too big production plants. And with all these TCOs, I do not calculate any subsidies. A little bit more about our company. We are a growing scale-up, and we are designing and manufacturing in the Netherlands. We do not do all the work ourselves, so we have good partners for assembling and for making all iron work. Our core business is the market on one hand, and the development and the software on the other hand. The company is owned by 3 family investors. We work with European suppliers, some from the Netherlands, a lot from Germany, Slovenia, UK, and some other smaller countries for smaller components. So now and then we try something from China, but that is never a success. The partnerships for the steelwork, we have some components made more or less ourselves, designed more or less ourselves, especially around the motors, and we are doing that with good partners. And for the assembling, we also work together with partners. Our customers are more or less agricultural based, and then we can talk about 2 groups. It is about the controlled traffic farming group, and there you must think on farmers with big arable farms that use their GPS to drive always around the same tracks in their field. And by doing so, they have a lot of compaction on that small track, but they have almost no compaction in the soil between that. And that makes their harvest 15 to 20% higher with a better quality. So there is their win. The second group of farmers are all the farmers with solar panels and wind turbines and all kind of energy solutions. And that is also in the Netherlands quite a big group on this moment. And then the second big group of customers is the infra-based companies that are forced by their clients to work emission-free. And then a bit more about our history. In fact, the first sketch above is the first 2-dimensional design of our first prototype made 10 years ago. And that designer not even worked with a 3D program, so that was only 2D. And then I decided, well, you cannot discuss with farmers about a 2D print of a machine. You don't see anything. So we skipped him and we fly the new engineer in with good work with 3D. And then we had immediately discussions on the table with these farmers how that machine should look like. So also there you see that new technology is really giving new possibilities. Somewhere in the process the electric drivetrain came in, and then we built 2 prototypes. You see them on the third image. But these machines, looking back, were maybe too big and too expensive. That could not go to the market. Technically they were very interesting, but a bit too much, I think. And then we rescaled it a bit to the machine we have now. So my question to you, how can our machine fit in your projects? And when you want to discuss this, please come in contact.
So questions, please. Actually, we have one from the panel, virtual conference platform from Jay. In practical use of your tractor, how many liters or kilogram of H2 is equivalent to 1 liter or kilogram of diesel?
We are calculating with something like 1 liter diesel for 0.16 kg of hydrogen, so that is more or less 1 to 6. And that is very depending the load case of a tractor. And a tractor is used in a lot of different ways, and it can be quite efficient, but a lot of time the tractor is in fact very inefficient. And depending what a farmer is doing with it, we can have a more or better fuel system, energy efficiency. Yeah.
Thank you. Any other questions?
Xavier Mel from Kubota. Thank you for your presentation. The fuel cells, is it one single fuel cells of 120 kilowatt, or you have a multiple fuel cells?
Yeah, a stack means multiple. So in the system there are a lot of stacks, yes. But in fact it is one complete system. So it is not two 60 kilowatt hour systems. It is 120 kilowatt hour stack system. Yeah. And how did you do for the cooling of the system? Was it a challenge? The challenge is the amount of hoses and not able to get the right water pumps with enough flow and not too high prices. So when I have to pay, I think, just the bare price of 1,700 euro for one water pump on a machine like this, that is a lot of money. So in the component world for electric vehicles like this is not ready yet. So we cannot find it, or it is too expensive, or it is not fitting our specs. Okay. Yeah.
Thank you.
Thank you.
Pascal Kiewitz from Bucher Hydraulics. I don't need to mention it, but we have such a pump. Quiet pump, we'll discuss. I'll contact you in this regard. But the question goes into the direction of, do you also provide a power beyond connection for the implements, and how big is that?
That is more or less the 100 liters oil, I think, with a pressure of 200 bar. So that is more or less the benchmark for this kind of tractor. Yeah.
And is that also, is that the same hydraulic system as you use for the steering?
Yes,
and your,
yes.
Okay.
We are working with one electric motor, one big electric pump, big hydraulic pump, and then two big valve blocks, front and rear. In fact, that are Bucher blocks. And then we have, with that, we have the complete hydraulic system. Yeah.
Thank you.
But we are fighting energy losses in that system. So when I saw that picture on the screen yesterday, that only the valves take half amount the energy, I think please go back and do a better job.
Thank you. Next question is going from platform J. Can you increase H2 pressure in the cylindrics to reduce the number of cylinders?
I myself am not able to increase the pressure. But when someone makes affordable pumps to do that, because it is not difficult to get a tank for 700 bar. That is doable. But we have to look to the complete system. So when we put tanks for 700 bar, the farmer has to fill it with 700 bar. So he needs compressors for 700 bar. And that is much more expensive than a compressor for 350. So it is a calculation of the complete system, and then the farmer can decide, or the user can decide, what components do fit me the best. But we can place the 700 bar cylinders. That is not a problem at all. But it's only a small part of the discussion. It is a bit the same with the chargers. Of course, you can charge it with 150 kilowatt, but that is an expensive charger. So overnight charging, that costs you nothing. But 150 kilowatt, wow, you have to pay for that. So yeah, that whole world is in development, and yeah, we have to wait to other manufacturers are making these systems affordable.
Thank you.
Hello, Fernando with John Deere. The question I had for your hydrogen, while you try to make it on a farm or on site for fuel cell, can you make the high purity hydrogen, which for fuel cell that's typically 99.97% minimum?
Yeah.
Are you able to achieve that level of purity for fuel cell?
Yes, we are, and in fact, I'm not, again. But our suppliers are able to do that, and they are already doing that just with electricity making hydrogen, and I think that is the way to go. So for the green hydrogen, then it is not that difficult to get it clean enough for in that stack. So there are a lot of systems running already in Germany and in the Netherlands with own produced hydrogen in vehicles like this.
Do you need a special water supply to make that high purity hydrogen?
Special?
Water supply, a high purity water supply to make that high purity hydrogen?
Maybe, but then that's part of their system, which they are selling. So there are all little tricks around the hydrogen stack, all little secrets which you have to know when you are using that kind of systems into your machine. But we are learning that together with the industry, and quality becomes better and better. And since I'm working with that supplier, I did not have any ideas of problems with the purity of the hydrogen. So he's just guaranteeing that it is pure enough. So yeah, the same is for the filters. The air has to be filtered out. So also for that there are solutions to clean it up. That was one of my concernings. Agriculture is always dusty and sometimes gassy around. So that can be a problem also. But that can be solved more or less. Yeah. Yeah.
Thank you very much.
Yeah.
Another question? Andreas Ocknott from EFORS. Thank you very much. I think the whole project is very ambitious, but it's very, very interesting. Maybe to make it even more ambitious, are you also considering automation?
Yes, we are.
Okay.
Yes. Of course we are. Because, and when I started with this project, my little group of farmers did not have any interest in automation, because they are full-time, very professional farmers with high yields and a lot of money in their hectares, and they want to be there because they are living from the last 2 or 3% of their harvest. That is their win. And then you have to do everything 100%. And automation is not that far. But now labor is becoming more and more an issue in our country also, especially a seasonable oriented labor. So, and now we are talking about automation, and a group of students now is working on 2 models of our EOX with software that can drive in a kind of master-follower situation. That is for us the first step. When that works, we can go to 1 driver with 2 or 3 machines, or maybe 3 machines without any driver.
Okay, thank you.
I think our tractor is ready for it. Yeah.
Yeah, hello, Piotr Pąkowski from Eton. Storing hydrogen in the tanks, do you see it as a challenge? Like how long can a full hydrogen tank last?
I do not get a question.
If you fill up the tanks, the cylinders with hydrogen,
yeah,
how long will they last with fully you know, with full tank of hydrogen? How long will it last?
How much work can you do with it?
No, if you fill up the tanks
Yeah.
with hydrogen
Yeah.
and not use the vehicle, will does it leak? Okay,
Yeah,
that's
yeah,
the word.
yeah. In the specs of the tank, there is a number for that. And it are, how do you call that, a material? That is, it is not a metal tank. It is just artificial resins with Kevlar fibers in and things like that. And there is a number in the specs for the leaking, but that is not that much. I think you can at least store them 1 year before missing a lot. But why should you fill your tanks when you don't use your machine? So, yeah.
Just one question.
And the problem with the diesel, that also becomes old, eh? And petrol is also becoming old, so yeah, you have to use it, otherwise don't fill it, yeah.
Just a quick question on the vehicle architecture. Is that what electric tractors will look like in the future? Most tractors have nose mount engines. This looks to be one of the first true ground-up electric design. Is there a reason the vehicle looks like that? Is this the best way you could make a tractor if you didn't have the constraint of an engine? Or
We did not have the legacy of 100 years Ford tractor designing. And of course, the concept of Ford was genius 100 years ago. But when you don't need an engine, and you don't need a gearbox, and in fact you do not need the rear axle, why should you build them? So, and of course you can discuss about four-wheel motors. Maybe you can better have fixed axles and one motor. That is possible. But yeah, time will learn that. And I think the way our concept is quite modular, and we are able to fit a lot of solutions, I think. So.
And do you think that this will be what electric tractors look like in the future?
I don't know. I really don't know. Yeah. What I see is that all other tryings of electrifying a standard tractor are difficult, because it is that nice compact concept. Where do you put your saw in, and what do you throw away, and what is resting then? So they have to rethink, I think, the concept. Yeah, and we did that. Yeah.
Any other questions? So thank you very much, Paul, for your great presentation.
Yeah. Thank you a lot. Thank you a lot.